Hello. So, good afternoon, good evening, everyone. And this is our live interaction session 6, and we are waiting for the students to join. And let us start in next 3 4 minutes. We will wait for other students to join. Thank you. Okay, so hello, hi, namaskar. I'm Prashil. I'm a Prime Minister's Research Fellow at IIT Mumbai, and here we are learning advanced thermodynamics and molecular simulations. This is our live interaction session for week 6, where we will be solving assignment problems, right? Yeah, so I hope you students have gone through the lectures, and that's where we are discussing, okay, the questions that are related to the studied portion, which can come in the exam, right? So in this week we studied, okay, how to calculate the partition function. So first thing that we discussed was the basic concepts of thermodynamics, right? Basic concepts we studied, okay. Then we studied probability, right? And there were multiple concepts that were there. For example, concept of ensemble. That means if I have a system like this containing some gas molecules or some liquid, and I want to study the properties of system, right, how it is evolving. So we take multiple snapshots, we took multiple pictures, and those pictures were collected, right? So it is collection of microstates. So those pictures are called as microstates. Those are many states of a big, those are many steps, right, that are happening in our system. So these are micro states. So multiple states we are visiting as we are moving, right, in time, when the system is in equilibrium. So those snapshots we take, and we call them as micro states, and those micro states are then used to study system, right, using probabilistic approach, probability, right? So we calculate something called as likelihood of uh, that system to present in a particular energy state, right, w, and this w is then related to multiple free energies, right, depending on the system under consideration, right, depending on the system that is under consideration. For example, if I have a system where number of molecules are constant, energy and volume is constant, right? For systems, we know that this is the expression kb ln of w will give you the number of ways, that is by which we are distributing energy E in n systems. The W will come, that is called as a multiplicity. W is the multiplicity, which is equals to 0 when temperature is equals to 0, right? Therefore entropy W is equals to 1, not 0. W means number of ways in which I can distribute the energy. There is only one way, all the molecules will be in the ground state. So this we have studied in the class in detail. So S is equals to kb ln 1, ln 1 is equal to 0, so S is equals to 0. So this minus of 273 Kelvin, right, will give you the reference for entropy. Similarly, for other, can you find out what will be for NVT that we have discussed in the class? We are just noting down what are the major observations in those particular, right? What is for NVT ensemble? Please tell me. For each type of ensemble, we have calculated this property, right? For NVT, we know it is Helmholtz free energy, right? Where the volume of the system is constant. Consider a system where I am heating water in constant volume. So how do you imagine this? For example, pressure cooker. Here volume is constant, right? Number of molecules are not changing. So this is my NVT system, right? For this we know it is KBT ln of QNVT. For each of such systems, we calculated what is the free energy, right? So this is a relation. Similarly, for NPT, which is isothermal, isobaric, ensemble, and then there will be mu VT ensemble, right? Mu VT ensemble, right? For this ensemble, what was the value? What was the expression? So we know that expression was H, that is what is my free energy, is equals to KBT ln of Q NPT. So here it will be two summations. First we will do summation of all the energy states, that's where it is my exponential minus of beta EJ, correct? and in second case we will be changing the volume. So summation over all the possible energy states and summation over volume for different volumes. So particularly we will be choosing first of all a particular volume and calculate what and all EJs are distributed, and then change the value of volume, and then there will be minus of beta, and here you can see delta V, right? And delta parameter we can calculate from constraints that are given. This we have covered in detail, huh? Constraints, right? So now what is the answer for mu vt? Similar to this, which is npt, what is the answer for mu vt? Right, here it will be grand free energy minus of kbt ln of q mu vt, right? And then q mu vt can be related further to summation over all the states with energy n, number of particles n, states with number of particles n, and then there is ej, correct, exponential minus of beta ej minus of gamma n. So first you fix the value of n, calculate what and all energy states are present in that particular n, change the value of n, calculate this. So here we can calculate q, particular n is there, which is q n vt, right? q n vt. So what we did here, this can be broken down into two parts. One is energy change, other is the number of molecule change. So the energy change is happening over here nvt, that's where the temperature is constant, and that particular value is for a given n. So we are just integrating, we are just summing it over different n values, and here you will find out that gamma is equals to beta into mu. This you can substitute and get the final expression. So this is how we have solved these things for multiple ensembles, right? And based on this background now we will be solving the questions, right? The first question is there on your screen. You can see Helmholtz free energy F is related to canonical partition function. We know Q is equals to minus kBT ln of, sorry, this will be F Helmholtz free energy kBT ln Q. Again, the detailed derivation is there in the lecture. correct? And beta is equals to 1 divided by kbt, so it is minus of ln q divided by beta. So answer to this question is minus ln q by beta is equals to f, that is option number A. So this is the correct answer for the question. Correct answer for the question. The questions are relatively easier in this assignment and most of them are theoretical except one or two, right? So question number 1 is done. So now let's move on to question number 2, which is again basic question talking about variance. So try to solve this. So you need to get understanding of how energy is changing with the time, and then you need to get an idea about standard deviation, and third one is variance. So there is a relation between standard deviation and variance v, right? Variance is equals to standard deviation square. So please try to find out answer. So did you try? So let us solve this part. So we know that if I have a system at room temperature, it keeps on exchanging energy with the system to keep the temperature constant. To keep the temperature constant, right? To keep the temperature constant. So this is how energy is fluctuating. So this is the value of E, and this is with respect to time. So now I'll just calculate how many times the energy falls in a particular interval, and then I can draw something like this, which is distribution of energy. Distribution of energy, right? And the energy you will find is fluctuating around a constant value. So what is important is how energy is varying, and to quantify the variation we calculate something called as energy distribution. We plot it and then calculate what is average energy and how it is fluctuating around that constant, which is given in terms of sigma E, that is standard deviation, right? Is how we get the standard deviation, which will tell you okay what is the spread of the curve. Spread of distribution. Spread of distribution. So we are basically calculating how a value is fluctuating around a average value. So the formula must be how energy is fluctuating around average value. Now you can say okay, if we calculate, when we calculate this deviation, right, some of the values will be positive, some of the values will be negative, and then you know that this is a Maxwell distribution, or I should say binomial distribution, right? Or it could be multinomial, but then in everything we will find out okay 50% of this is equal to 50% this. So half of the energy values will be positive, half of the values will be negative, and hence this will be equal to 0, right? So we cannot calculate this property, and that's where we calculate what is the square of this value. We sum in it, right? We sum this value, that is E, how E is varying with respect to the average value from the average value, correct? And then this value we take summation over n systems divided by n. So basically it is an average of E minus of E average, E minus of E average square, and this is what is the average value. The bar represents the average value, right? So option D is already there, right? Option D is already there. Now we can expand this and we can expand this, we can give it to every term, average of all. So this will be E square, and then average of it minus E average is already there, square of the value, and then average it again, and then there will be 2 E average square, E average square, right? So what you are supposed to get? You will get E average is square of the values, right? Take their average, then plus average value square. So I have an average value, I'm taking square of that value because average value is only one value, right? It is not changing, and again average of that value, which is equal to square of the average value minus of 2 e square average, right? So this will be 2 e average square, right? Because here I am taking the average value and again I am doing it square, right? Which is equals to this one square of the average value, and then we take. So upon solving, you are going to get e square average minus e average whole square. So option C is also there. So both option C and D are correct, right? Both option C and D are correct. So option C and D that we got for this question number 2. Then question number 3, which is easiest question again. Canonical ensemble, right? We know multiple names are there. For example, NVE ensemble in statistical mechanics. We are just referring it by some word names. So this is called as microcanonical. NVT is called as canonical. This is our particles and this is our systems, and we also let volume to change, right? So this is what is isothermal isobaric, and then we have mu vt, which is grand canonical ensemble, right? So for this question we will limit ourselves to nvt, this that is equals to canonical ensemble. in statistical mechanics, right? So option B is correct. Option B is correct. Then question number 4 is there. Variance. Variance, we know, we in class we have solved how energy is varying, and it is related to average E, right? And then we got the formula that T is equals to minus of del E by del beta. Minus of del E by del beta. So option minus del E by del beta, this value. This is an average value. How it is varying, that we are going to calculate in question 4, right? So let us now solve question number 5. Question number 5 is there on your screen. So it is written what is the canonical partition function. The expression is given as alpha beta beta raised to the power n, and here beta we know it is 1 upon kbt. So they are asking us to calculate the variance, energy variance, del E by del beta, right? This is what we saw. So from the class notes, if you know, the value of variance of energy is related to del E by del beta, and when you calculate this you will get an expression. This has been derived in the class. I am just writing the equation: del 2q divided by del beta square plus 1 upon q square del q divided by del beta whole square, right? So in this equation just calculate what is the value of del q by del beta. Alpha is there, n will come here, beta n minus of 1, and del 2q divided by del beta 2 is equals to alpha n minus of 1 beta raised to the power n minus of 2, correct? N minus 1 beta raised to the power n minus 2. You just need to substitute the values here and you are going to get the answer. I'm just doing for I'm doing it here for you. Sigma square is then equal to minus of 1 upon q. So q is what? Alpha beta raised to the power n, alpha n square minus of n beta n minus of 2 plus 1 upon q square alpha square beta raised to the power n, and its square is equals to 2n into alpha square n square beta raised to the power 2n minus of 2. So I'm going to get sigma e square is equals to alpha beta raised to the power n, beta raised to the power n minus 1. So this is equals to beta raised to the power n minus beta square will be there, right? nn. So beta square n square minus of n, and then there is minus sign, plus alpha square cancels, n square will be there, and then beta 2n get cancelled, so it is 1 by beta square. So we can see this sequence equation becomes minus of n square plus of n, correct? Minus of n square, this is plus beta square, this and this is getting cancelled, so n by beta square. So n by beta square is the value of variations in the energy. So option B is correct for question number 5, right? So I think it is easy, but then you have to do some mathematical manipulations here to arrive at the expression that is required. Then partition function in grand canonical ensemble, we have discussed at the start of the session that it is equals to q mu vt is equals to summation. There will be two summation. One will be over the number of particles, other will be over the energies. And it is equals to minus of beta ej minus of gamma into the n, right? So what we are doing is, first we will be keeping value of n constant and we will just integrate over particular n, so that is for a particular nvt ensemble, and then we change the value of n, so this is q nvt, and then we are keep on changing the value of n to get q mu vt. This is also one of the way of representation. So the required expression is there, n summation over j this. So option number 4 is correct for this question. Summation over n summation over j. Correct? So this is the expression. Now do it for the other question number 7. Question number 7. What is the value of gamma that we get? We get gamma is equals to mu into the n, right? There is a derivation. The way we have the derivation for beta, which is equals to 1 upon kbt. Kb is Boltzmann constant, right? Similarly, gamma we get is equals to beta into the mu, beta into the mu, right? So this is option number 4, which is correct, and then q mu vt will be equal to minus of kbt. Previous question, right? Here you can see we can substitute the value of gamma, so it is equals to summation over n and j plus gamma n. So gamma is what? This should be minus of gamma into the n, which will turn out to be plus beta mu. So you can see energy is there, and this is a forcing factor. Beta is also there, which is controlling, right? This is how it is. So option D is correct. Option D is correct. All are the theoretical questions. Now variance, again it is asking for the variance, just like we used to calculate what is the variance of qnvt with respect to beta, which was giving us the value of average energy, right, related to this. Here del q mu vt divided by del gamma, right? What is this value? Find out what is that value. Here we are getting variance, that is variation in the energy. Here we are going to get variation in the number of molecules. So this average value will give you how number of molecules are changing, right? How number of molecules are changing, that is variance. This, right? Both are analogous. See, when we have nvt, here it is mu vt analogous. Here I am getting q nvt, here I am getting q mu vt, and here I am getting free energy as Helmholtz free energy. Here I am getting energy as grand free energy omega, right? So these are analogous. The factor beta is here, and here factor gamma is there. So this will give you the average energy. This will relate it to the average number of molecules. Correct? So analogy is there. Now the last question of the day. Try to solve this question. Try to solve this question. So question number 9. Gives free energy. G is again related to minus kBt delta, and this delta is related to partition function of NPT ensemble, right? So this is the option A, that is correct. Option A is correct answer. NPT here again, as we see last time, summation over volume, summation over energy, exponential kBt, or I'll just write beta Ej, then minus of gamma into the n. Right, so this is the answer. So in this class we have solved assignment questions, right? And the video will be available on YouTube so that you can watch and look after the solutions. Correct? So that's all from my side for today's session. I'll be here to solve the questions if there are any, right? Please let me know. So if there are no doubts, we can close the session and let's meet in the next class, which is scheduled on next Tuesday. Thank you so much for connecting. Let us meet in the next class.